fields.
Yeah.
Who's an electrical engineer or a mechanical engineer? You are?
Electrical.
Yeah, we should talk.
Yeah.
And,
So is there a
but you have
model,
really
sample
need to
model,
build a
smaller model in running place or something?
Not really. Like smaller models are not like GPU. You need GPU to get.
So they are like bigger models,
it,
right?
Yeah,
So,
yeah.
So what robotics are these? Are these industrial? Are these
Humanoid
Hey,
robots.
human, he's talking about
Because human is
humans.
very general purpose, right? It
Humanoid
can do
ro-
any task at home.
Yeah, it can do. It is capable. So this particular robot is Neo, which I think everyone has heard here about it. And like
So
this,
one question before you move forward on the previous slide. Do you know what is the projected potential market? You showed the money
$1 trillion.
base, let's say in 5 years.
$1 trillion because
$1 trillion.
every
In 5 years, 5 years this thing won't be available.
No, the how much investment will happen in that?
Investment. Oh, there's already a lot.
yeah, since within 6 months 55.8 billion we got.
I know that people with a lot of money they want to do this.
Yeah, exactly. Everyone is like investors are literally moving to
Yeah,
physical AI.
it makes sense to do this.
A lot of companies are talking about this. Like recently, the Micron's result came out. The CEO was talking about the need for faster memory for the robots because the intelligence basically needs a very fast
Real-time processing.
Real-time processing.
That's
That's-
where we need to invest. She, the company, the next memory. More than this.
Correct.
Real-time inferencing speed is important.
Yeah, 100%.
But I think I'm sure that there are people there that are already thinking about to build probes that you can put it, it may not be invasive, that they put it in your hand or whatever to make you really gather good data. Because if you're going to do supervised here,
You can even put them on the robot itself, right? To learn.
Yeah.
Yeah.
And the revenue projection is 1 trillion.
Yeah.
In when?
it's more than that.
Yeah,
The revenue projection here is infinite.
1 2 years you said?
Yeah.
Okay.
The revenue,
Yeah.
you're going to have a robot with all this stuff in 2 years?
Yeah. So, you think more?
I mean, see,
I talk about 15 years.
It won't take that much time now. Like before, it was kind of expensive because I will go forward and share the earlier version as well.
Okay.
But now coming back to the
So models are mostly like private enterprise models that are trained, or anyone is publicly available?
there are a couple of models which are publicly available, but major exclusivity is maintained around as well.
So anyway, let me ask you, since you said 2 years, I'm into. So we have had robots in factory for years.
Right.
Right? What is this thing? What do they think that it is this to replicate a human or a dog or what is this called? Because I thought that this was to replace humans and to do dangerous work or whatever. Is that which one is it?
Yeah, dangerous work part is correct. So if you
So this is to replace a person.
correct, yeah. So coming to this part, like there are 4 sources which gets the data. Before, like until 2026, it was teleoperation data, which was like the hand sensors and every bodysuit was there with all the sensors, and then the
So they have
data
that
was
already.
collected. Yeah,
They
and
have that.
yeah, they have that, but it is very expensive in terms of executing and getting large number of data points. So if you think like the industries were already having the robots to do their mechanical jobs, correct? Like lifting from the top of pile and like delivering and packaging and everything. Those were the tasks that was done through teleop data, like folding a box, closing the box and everything. But it is very expensive, and again, it were very specific tasks. So if you think like going into a to open ground in a solar field, like where solar panels are getting populated, to maintain and fix those things without considering the weather change, it is not possible with current scenario, right? If it is raining, it won't go there, but after raining there will be still mud on the ground. So how it will be tackling that, how will it be walking on that, how it will be getting the solar panel out, then cleaning it. So how much pressure should it plant there? So all these things are getting through the teleop data was there, but again egocentric data is much more focused towards the humanoid part of it, which the screw fitting jobs, the solar panels only when it is not vast scale but it is very small scale, then it can be helpful in that approaches as well. Doing the laundry jobs, the sensors, the data points are getting more compared to what teleop was able to provide.
So when you compare these models to the regular models out in the field, how many parameters are we approximately talking? How large are these models? How many billion parameters?
Yeah.
Now how many?
8 billion parameters was there recently.
This is going to video, and will make word parameters. The video is every
Yeah, but that's
every
what
frame.
the weights and all are trained, right? Eventually in the model you get these billion, 8 billion, 10 billion
It's going to
parameters.
be a lot. This
Yeah, depending on the
video is
task.
going to
Exactly,
make
yeah.
is going to make the parameters of the LLMs now.
Because
child play.
Are these models specifically tasked or designed for certain areas, or they are generic models?
Yeah.
it is getting more towards the generic part of it and not getting focused towards it was initially very specific task models, like industry was separate, day-to-day home activities were different, but now it is trying the data is helping them to make it a generic purpose, so anywhere it can go, it can work around it.
What is Opus using? You know, Opus, Tesla's humanoid robots?
So that helping in the test, the Fremont factory, right?
No, they are building general purpose robots now. The Opus line is supposed to be general purpose robots.
Oh, not heard of that.
Oh, right, okay. That's why he's investing most of his money now.
But yeah, even XAI
Yeah, exactly. XAI.
for Black Robotics, I got approached for XAI to collect the data as well. So that is going insane. You were
Yes. My question was about a generic one, right? So I envision buying one robot for my house.
Correct.
Okay, let's take only two simple use cases. Put in cleaning the dishes, loading the dishwasher, and doing the laundry and folding the laundry.
What do you have your wife for?
But
Just
no. I understand that it can recognize a shirt versus a egg on a pencil. You can understand, but it cannot understand a paper ball versus a ceramic ball, right? So which goes to dishwasher, which doesn't. Clearing the place before putting in the dishwasher. And when doing laundry, you need to recognize the silk shirt versus a cotton shirt, and the color versus white it can. But
Correct.
my question is, I think they are going to hit a bottle, hit a wall, where recognizing tactile, what type of material I'm handling with.
Correct.
Right? So dishwasher and within clothes, they're so much more complex.
Correct.
So,
I was not even getting to your point, but yeah, the point is, I was just talking
Similar
about
example.
direction itself.
So those are done through the humanoid robot's fingertips, not through the
correct,
egocentric.
correct. So
data.
that's material science. That's what I'm saying. That brick
Material-
it's nothing to do with AI or the
Exactly.
data and videos and feeding ML. It's basically
Feeding is there. The data, like if you hold a paper cup, so how it feels, we need to provide the data.
complete. Yeah,
Yeah.
exactly.
Can I argue his point now? There's nothing different, because you can teach it to the tactile stuff.
Correct, but-
He's doing all kinds of things there, which I hardly believe in, but given
Correct,
that he
that's
can do
material
that,
science,
he can
yeah.
he can do the tactile stuff too, and the color they can distinguish. What about the smell?
It is getting developed.